Right, we are done for now with the terrestrial planets, but we need to go into the outer solar system now and talk about what are called the Jovian planets. All right, so we are pretty familiar with this slide by now. Remember how we divide up the solar system? We have talked about the inner planets here. We will try to hit the asteroid belt a little bit later. But for this lecture, we are going to talk about the outer planets right here. Um, Really, it starts from about 5 AU around Jupiter and extending all the way out to 30 AU. This is the zone of the Jovian planets. And these planets are, of course, Jupiter, Saturn, Uranus, and Neptune. Jovian planets are quite different in structure and composition compared to the terrestrial planets. They are mostly made up of hydrogen and helium, but there's also some ice and rock. So we have to be careful here when we're talking about gas, ice, and rock in the context of Jovian planets. A gas in this context is primarily hydrogen and helium, the two most common elements in the universe. Ices are the next most common elements, which are oxygen, carbon, and nitrogen. Rock are even less abundant than ice. It's basically everything else. So for outer planets, we're talking about magnesium, silicon, iron, etc. These planets are often lumped together, right? Jupiter, Saturn, Uranus, and Neptune lumped together under the term gas giants. But really, the composition of Uranus and Neptune are enough different from Jupiter and Saturn to warrant some distinction. So each of these planets are mostly made up of hydrogen and helium, but Uranus and Neptune have different composition and structure than Jupiter and Saturn, as we will see. So to be more precise, we should call Jupiter and Saturn gas giants and Uranus and Neptune ice giants. So there are some basic properties of Jovian planets. This is table 11.3 from your book, and it summarizes some of these properties. So you can tell that they are much more spread out than the terrestrial planets. We have four terrestrial planets kind of in a 3 AU span. Um, but if we can tell, Jupiter is about 5 AU, whereas Neptune stretches all the way out to 30 AU. So the distances between these planets are very large. All of these planets are very massive compared to Earth. The least massive of these is Uranus, so only 14 times the mass of the Earth. But Jupiter is far and away the most massive of all 8 planets at 318 times the mass of the Earth. All of these planets also have very short days, right? The Jupiter day is less than 10 hours, and Uranus has the longest day of any of the Jovian planets, and it's only just over 17 hours. There are a number of issues that kind of complicate the exploration of the outer planets. Um, you have to travel really far. So flight times are kind of on the order of, years rather than months, sometimes decades if you want to get really far out. It takes hours for messages to be sent back and forth, even at the speed of light. Um, these are just a couple of the problems. But all of these planets, each of these planets, these outer planets, have been visited at least once, despite all of these problems. So Jupiter and Saturn have been visited by missions called Pioneer, Voyager 1, Galileo, and Cassini, or sometimes it's called Cassini-Huygens. So Voyager 2 is the spacecraft that performed flybys of all 4 outer planets called the Grand Tour. It flew by Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989. So Voyager 2 is the only spacecraft to have ever visited Uranus and Neptune. The Galileo spacecraft and Cassini-Huygens were orbiters that deployed a probe. So Galileo deployed a probe to Jupiter, and Cassini deployed the Huygens probe down to Saturn's moon Titan. One of the defining features of the Jovian planets are their deep atmospheres and opaque clouds. Each of the four outer planets have mostly hydrogen and helium atmospheres. Jupiter and Saturn have really a similar composition to the Sun, in fact. Clouds on Jupiter and Saturn are made from frozen ammonia crystals. Deeper cloud layers consist of water and maybe ammonium sulfide. The upper clouds of Neptune are made of methane. Um, we don't see an obvious cloud layer on Uranus, though it's just kind of a deep haze. And if you look at images of the two planets, they're very similar, but you can kind of see what I'm talking about there. Uranus is more featureless, whereas Neptune, you can kind of see some streaky clouds. Deeper cloud layers on Neptune are actually probably made of hydrogen sulfide. Of all these planets, um, well, all these planets have deep, thick atmospheres, but the structure of the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune, they're quite different from each other. So this is figure 11.7 from your book. So Jupiter and Saturn are really dominated by hydrogen. Not only molecular hydrogen gas, but they each have a metallic liquid hydrogen mantle before you get to a small core of rock and ice. We have Jupiter and Saturn, kind of the gray and pink here. This is different forms of hydrogen. So you can see most of the planet is hydrogen in some form. In fact, most of the interior of these two planets is actually this liquid metallic hydrogen. Uranus and Neptune are not massive enough to create the pressure high enough for hydrogen to become a liquid. So instead, these planets have an atmosphere of molecular hydrogen and a core of rock and ice. Even though we say, rock and ice, there's cores of rocks and ice and all of these planets, even on in the smaller planets, Uranus and Neptune, um, the rock and ice are under immense pressure. So we can bet that the rock and ice that's there do not actually take forms that we are really familiar with. These pressures are really kind of unbelievable, and we don't see them really in our day-to-day life here on Earth. The last thing I want to talk about for the Jovian planets is their internal heating mechanisms. So Jupiter has the largest internal heat source, which works out to be about as much heat coming from this source as Jupiter absorbs from the sun. So this means that Jupiter is kind of like a hybrid atmosphere, right? It's partly like Earth's atmosphere, which is heated mostly by the sun, and partly like a stellar atmosphere, which is really heated from the inside. It's so massive that this is kind of what happens. Saturn has an internal heat source as well that is half as large as Jupiter's. And the source of this heat is differentiation, right? This process where different molecules and elements separate. Like, we talked about this with the terrestrial planets, where kind of the nickel and iron in kind of a molten planet, they're kind of the heaviest elements, so they're going to sink to the core, sink to the bottom, and let all the rocks and stuff float to the surface. And that's what's happening here in Saturn, except that we're talking about Saturn's liquid mantle, where there's liquid hydrogen and also some liquid helium. Helium is a little bit heavier than hydrogen, so the helium will slowly drop to the bottom of the liquid mantle, and it will release gravitational energy as it does this. And so this drives Saturn's internal heat source. Neptune has a very small internal heat source, but Uranus has no measurable internal heat source, so none that we know of. Okay, so that is it for this lecture on the Jovian planets. Remember to take your reading quiz and email me or come by my office hours if you have any questions.